So this is what I'm going to talk about. Introduction, I have to background and motivation, look at literature review, look at some objectives, research question and formulate some hypotheses out of there, and then data, and talk about research methodology, discussion of results, and look at some of the findings and implications. So that's the program. Now, that's the background and the motivation. Why am I doing this? What's the reason for this? So this is from my own teaching experience. Particularly, I teach finance courses, which is quite quantitative. And what I find, I'm not getting the best results that I would like to get in finance courses. And up to 20% students fail introductory courses. So anywhere between 10 to 20% students fail. And another problem that we're facing is, plus large portion of the students are amongst this, C and C plus grades, and what we get is a very much left skewed results in our introductory finance courses, and it's same with the accounting courses as well. And I'm saying that this is different from my experience at other universities which I have taught, so they're a bit more centered, the results are much more better than what we're getting. So this is the reasons that are sort of motivating me to check. And lower grades become a bigger problem in higher quantitative business subjects, poorer. So it sort of cascades down the higher level of subjects, 200, 300 level, and we're more or less struggling towards the end. And as you know, finance has been a new course this time around. This is the first semester where I'm getting the 300 level finance courses, and I tell you what, it's becoming very difficult. And so the general observation is numerically weak students, particularly in the area of business mathematics. And other reason why I got motivated to do this analysis was together with other colleagues in Faculty of Business, we did this Vice Chancellor's research project on destination survey of secondary school students, which was the OSAID funded student. In there we looked at where the students are coming from around the region, who are coming to USP, or if they're not coming to USP, where are these students going from? Basically, that's what that survey was, amongst other things. And what we found in there was top students from the region get scholarships to go to New Zealand and Australia, and they don't come to USP. So that was quite a interesting finding, or concern finding for us. And USP cohort was largely from the 20 to 40%. If you look at the aggregate mark lot. So we were attracting mostly this sort of middle range students. The top students were not coming to USP. That was the finding, and that's not a concern. So that's all sort of said, okay, right, we have to look at, I decided to look at the entry point and see if the entry system or our recruitment system has something to do with it, and that's the reason for doing this. So I checked out some literature. There is quite a large literature showing strong need for high school mathematics for tertiary science program, and in particular computer science. So there's quite a lot of literature in this area which shows a very strong positive correlation with high school mathematics and science courses, and particularly computer science courses. Mathematics effect on education, law and economics course. Also there's literature there showing finding mathematics skills inadequate. So this is some literature there showing that mathematical skills are inadequate, surprising for education and law and economic courses. Right? And there's strong correlation between high school accounting subjects and tertiary introductory accounting subjects. And there's again quite a bit of literature on there which is showing that students who do well in high school accounting do well in accounting subjects in universities, plus other business courses as well. That's what this literature is saying. Moving on. Not many research have examined the effect of high school mathematics on tertiary business courses, right? There's only a few. Business courses means accounting, finance, and the rest. There's a literature on science courses, particularly computer science courses, law and education, but not so much commerce or business, which is accounting or that. So in summary, I'm summarizing, there is a strong link between high school mathematics and science courses, particularly computer science, inadequate mathematics skills with education and law, and there is scarcity of research examining implication of high school mathematics on business courses. And here I mean particularly accounting, economics, and finance. Three I have selected for this study to look at the impact of mathematics, particularly on the performance of accounting, finance, and economics courses. I'm identifying them as quantitative business courses. So with that, I formulate objectives and intuitively there is an expectation of mathematics as a prerequisite among other subjects. I think that's quite a well accepted fact. Everybody thinks that you must do maths, it's very important, and but this study here formally examines, so this is what I'm going to do here, the impact of Form 7 mathematics together with Form 7 English, accounting and economics on the likelihood of passing quantitative business subjects 1, 2, 3, finance, economics. So I'm checking the effect of mathematics together with English, accounting and economics. So if you look at the aggregate weight of the tertiary entrance from high school, these are the subjects in there, mostly core subjects. And then impact of the Form 7 mathematics together with English, accounting, economics on performance. This is the likelihood of passing on aggregate level, and this is the performance grade wise. Are they getting just passing or they're getting good grades as well? So that's that. And then this is more like a control variable in my regression analysis, which is my research method. Impact of aggregate tertiary mark. I am calling it ATM, obviously the bank ATM. But this is the aggregate tertiary mark from high school on passing and performance of quantitative subjects against 1, 2, and 3. So, and with that, I move on to formulate some hypotheses to test what I want the results for. And the hypothesis, this is the first level, which is talking about aggregate pass, the ability to pass or fail. And as I said earlier, the second will be the performance, the grade. So for here, I'm saying the likelihood of passing introductory business course is positively related to Form 7 mathematics qualification. So that's I'm sort of changing the question into hypothesis to test it. And likewise, again, the likelihood of passing related to aggregate mark, which is my control, and then each of the subject positively related to English, accounting, and economics. So these are the high school aggregate mark, impact of that on likelihood of passing in university, particularly USP, accounting, economics and finance, impact of high school accounting on that, impact of high school economics, impact of English, total aggregate, and impact of mathematics. So that's on the passing fail likelihood. The second set is on performance, which is the grade. Similarly, I set the same hypothesis, but talking about student performance in introductory business courses. For this research here, this one is 3, accounting, finance and economics, positively related to mathematics, and again aggregate, and again English, accounting and economics. So I formed that. One thing maybe I explain that this aggregate tertiary mark, if we find that these other dependent variables are non-significant, we would say that this aggregate tertiary mark is serving its purpose, because there should not be, this is like a grouped up subjects together, weighted to be the subjects which are supposed to have the most influence on the tertiary introductory courses, looking at 100 level courses here. And if we find anything else to be significant, would suggest that this control here is perhaps inadequate or insufficient, and which might call for, I'm preempting a result a little bit here, which might call for really looking at this basket, which is the aggregate mark, like the tertiary ranking from high school. And this is the methodology or the methods here. Again, this is the weighted average, where I'm going to look at the weighted average impact of, this is my concept of course, and this is mathematics. Now, if you look at, let me talk about the independent variables again first, and then I'll go to the left hand side. That's mathematics, again mathematics, aggregate rank, accounting, English, accounting and economics. Now, what I have done, if you look at the curriculum, particularly in Australia, they have at least 3 types of maths in Form 6 and Form 7. Maths in society, 2 units maths and 3 unit maths. And those, I think there's a key, those maths in high school target different things for the university students. I think that here we don't have that. So what I did, I broke our mathematics into just pass. So that's mathematics / P, which is my 1, and then B plus average above, which is B plus the students who are going to get in high school, B plus average and above. I'm like treating here like mathematics B in Australia, A and B if you like. I mean, not exactly, but I'm trying to. So that's what I've done. And this, the ones, so that's 1 and 2, the ones telling me passes and 0 will be fails. If they pass or they fail. And this is the average on the aggregate side, so average weighted. Q will tell us if the proxy, the weighted average, for example, if they do 6 subjects in first year or 5 subjects on that. So I take the weighted average, and Q1 will mean all subjects pass. So Q over 1 minus 1 over 0, so it will be 1, that means all the subjects they have passed, and if they fail, Q will be 0, and that will give the aggregate on the other side. GPA, grade point average, as you know, I'm taking that to measure the performance from low GPA to high GPA, and again, this all remains same. So this here is just a repeat of 1 and 2 for my accounting, economics and finance. So this pass or fail, and this again performance. So this is the broad aggregate, and this is for my pass fail. Okay, after that let me go to results, overall results. What we find, successful completion of Form 7 English, high mark in mathematics and high aggregate mark were found to be significant when passing aggregate overall. So these 3 things were found to be significant for passing, overall likely passing. Importantly, higher mark in mathematics was found to be most significant in passing the quantitative business subjects. And this was again same as corresponds with finding of other research. However, just passing mathematics, in other words, in Australian equivalent, maths in society perhaps is not very good, whereas maths B and C are good, was not so good. Just passing maths, accounting and economics were not found to be significant. That is, they did not make any more likely of passing than the aggregate mark. So they independently, they did not play any extra role, if you like, but maths or mathematical mark did, to understand that, if you want. And that's again the same with quite a bit of literature there. Probability of passing individual, so that was all grouped up. Individual, again, higher marks in mathematics coming out strong to pass. Accounting were found to most significant for student passing accounting, finance and economic subjects. So higher mathematics were quite relevant or influenced in passing this. Higher mathematics are again correlated passing introductory finance and accounting course. Again, the pass in mathematics did not make much difference. Higher mark, clearly. And I'm doing this research, so this is a smaller part of a bigger research. And this is coming out quite intriguing to me. and I might do a bit more work on that. For passing accounting, Form 7 accounting, of course, had influence, but the correlation of that was lower than the higher mathematics marks. Interesting, I'm saying. So accounting, high school accounting has influence for students performing better in tertiary accounting, but less than the mathematics marks. Right? Coefficient were twice as high, again, this finding here, and there's few more, quite same as that. That maths plays a more significant role for students passing accounting in university than accounting subjects in high school. Individual continues. The finance course was interesting too. The coefficient was also significantly high. The maths, but the residual for finance was quite high. In other words, all those vectors that I have in the regression were not catching up. There's quite a residual coefficient, which tells us that something else is needed in high school for the students to do well in finance courses in universities. An answer perhaps is that we need a finance course in high school curriculum. At the moment we have accounting, economic, maths and English, but we don't have a finance. So that's, I'm saying, some maybe a high school policy implication and all that. English, aggregate mark and economics were not found significant. English was not found significant to have significant influence on quantitative subjects. That may be again but true. I think there is quite a belief that those who do better in English don't do good in maths and vice versa. So probably that's what it's coming here. I don't know, something to do with way our mind functions. And that's again was correct, same as the Reeds and Alcock results from Australia. Individual subject, English was not found, as I said, finance accounting. 18 was not found so significant, lesser extent. In other words, as I said earlier, this tells us that we might talk about doing something with this and changing. Other subjects, these aggregate marks include other subjects which are perhaps not that influenced in high school. Performance, same thing. There was likelihood of passing aggregate and individual subjects. Performance, higher mathematics is coming strong, same as before. And just past mathematics is not doing good. Same relation, not found with English and the aggregate marks. So mathematics coming strong, English and not coming. Okay, time's up. I think you can take a few minutes if you don't mind, please. And what I'm saying is higher quant skill students achieve higher grades, and maybe you have to look at GPA, maybe you have to look at, I want to go to this, if I may, DVC, Kelly, 1 or 2 minutes, to look at the reweighting of the aggregate mark that we have. We might have to rebasket it, include some other things in there. And literacy is important, of course, but English is really not having much impact on quantitative type subjects. Really look at how we interpret ATM for our recruitment. Mature age, some studies included this, whereas I could not depend given the data constraint, but I guess that mature age entry might be doing something here, which the other studies found it quite relevant, that people after high school, if they went 1 year or 2 year and worked, when they came back they had a better maturity, understanding and able to do things better. So I think I'll leave it with that. Thank you so much for listening to me.
Thank you, Rohit, for very good analysis and presentation. But I want to know what implication you think it has on the university's policy of having introduced generic courses across faculties and across departments.
Yeah, I think that's a positive move. What I would say, if we could add a mathematics, a remedial type mathematics and numeracy course there, that might help our course as well. So you have two, I don't know, I'm probably saying third one as a numeracy, remedial numeracy course. Because it seems that students And it also depends on the curriculum of the mathematics, high school mathematics, what does it entail? Like if you look at our overseas countries, for that very reason, they have got 2-3 types of mathematics in high school, and they try to narrow it down for the students, specializing in whatever course they want in university. Here we have a very generic one, and our mathematics, if you look at the mathematics curriculum, it's very much biased towards scientific mathematics rather than business or financial mathematics.
Thank you very much, Rohit, for that presentation. We have already numerous studies of similar nature here at the university confirming your results. And these are published work in the already appear in the web. And accounting and business programs here already allow for that factor, mathematics factor. Accounting and finance students require a 60% mathematics mark in high school for entry. They don't require any requirement for accounting course. Other university programs don't require it. So we already know that mathematics is important. However, the results are still not as good as we want it to be, as shown by our results here. And we suspect the problem is the curriculum that is offered in the high schools. I mean, even if we lift the mathematics requirements to 70% or 80%, I suspect the problem will not go away. I think it is to do with how the curriculum is designed in the high schools, how the assessment is conducted, and whether the authorities are shifting the goalpost when we shift our goalpost. I think we have had that problem, and there is something that's beyond our control. But I think it's a good idea to have some remedial courses at the university or testing or entry-level testing, and that will probably solve the problem because we can have control of how we assess things. Thanks.
Frank, you had a comment, then we'll come back to you.
Thanks very much. I just need to say, or ask really, which way do you want to go? I mean, this kind of problem affects quite a lot of subjects. And you've got two possible routes, haven't you? One is you become more exclusive, and you really set the bar much higher and more stringently in terms of mathematical competence on entry, or you say, no, we're going to be inclusive or more inclusive even, and that either means working on skills, developing a curriculum, but also, I was saying yesterday, we did a lot of work on math, particularly in our feeder schools, precisely to address this problem. Or, and we did this too, you've just got to do a lot of remedial work at entrance, and if necessary, you have to require a 3-month enrollment, particularly to do remedial work, the first 3 months or prior 3 months, so that you get students up to standard. I mean, for me, you go the inclusive route, but it means more work.
And it's certainly true, there's a contrast on remediation in UK universities so in the States. We're talking millions and millions of dollars, but as you know, education is expensive for ignorance. It's really very expensive for you to do it. You need to start with where the students are.
I was interested in the result that you got with regards to predictions of high school performance vis-a-vis finance courses at the university. You suggested that we need some kind of finance course at the school level now.
Yeah, elementary.
Well, I would agree with you because I think that it's an important life skill that students are able to deal with their own personal financial matters and so on and so forth. But I wonder if the fact that there's a high decision here is simply that the core courses that we expect students to take competencies in the secondary school environment, like mathematics, English and so forth, but just not as strong predictors as they are for other business-type courses. Maybe we need to look at something else in the university curriculum to ensure that we get better pass rates in finance majors.
Yeah. Some of the studies there, previous studies, as I said in my conclusion, they put in a gap factor there, which was like measuring student maturity. And when they included that in the regression, it improved. So I mean, here that's what I say. Future, when there is and it sort of goes with the policy that some of the things the USB is trying to do, that increase our mature age entry students, and they seem to show better results.
Well, I think maybe if you do a number of those things, which is really work with the schools, remediation,
and both,
but
yeah.
also the mature age students in a paper we're going to hear later, which is in the study buddy, mentoring mature age students working with younger students to help them see what you're talking about, practicalities and how this is useful to business.
Yes, and mature age doesn't mean that, sorry for my vernacular, old people. It means people who have left high school and went to do something else for a period of time, but they're still very young.
Well, old people can still think, right?
Oh, sure.
From here, I'm collecting at all twos.
Oh, yeah. We don't.
Working like a